All right, everybody. So we are looking at number 6 of the January 2024 Earth Science Regents. So number 6 says the diagram below represents a flagpole and its shadow in New York State at solar noon. All right, New York State at solar noon. It says the shadow is pointing from the base of the flagpole towards the what? Now, when you're looking at this question, it's tempting to just say, well, it looks like it's pointing, the shadow looks like it's pointing, you know, towards the northwest, right? It looks as pointing in this direction. However, what's important is that we need to know what is the location of the sun at solar noon. Because they give us this flagpole, but we don't know what the compass directions are, right? And so, because we don't know what the compass directions are, we are actually going to take a look at a diagram of the sun's path. So, when you're looking here, and I'll just zoom it in just to show you guys even more. Here we go. Perfect. So, one of the things that you'll see here is that I see the sun's path here during the winter, right? And the summer, right? And what we know is when the sun reaches its highest path, this is solar noon, when the sun reaches its highest path. Now, what do I know about the direction of the sun, right, that's facing when it reaches solar noon? Well, it always looks as though it's pointing towards what? The south side, right? And so if the sun is facing towards the south side at solar noon, then that means your shadow has to be in the opposite direction, right? So therefore, if the sun is facing the south side, right, then my shadow, as we see here, is facing the north side. All right, so to keep in mind, solar noon, the sun is facing south. That means that my shadow is going to be facing in the opposite direction. It's the opposite direction that the sun is facing. And that's why my shadow is going to be facing north, which means it will be, here we go. Let me clear this out. The correct answer will actually be choice 2. All right, number 7. Number 7 says, which term best describes the curving of Earth's planetary winds and major surface ocean currents, right? So I know in my reference tables, there are 2 pages that talk about this, right? We know on page 14 of the reference tables, right, we see the curving, right, of the Earth's winds as shown here, right? And we also know on page 5 of the reference tables, I'm sorry, page 4 of the reference tables, right over here. Let me do a little quick rotate. Yep. There we go. We also know that these winds, right, are also responsible for the direction of the ocean currents that we see here, right? And the question is asking, what causes this? Well, we know that when the Earth rotates, right, there is a special effect that causes the curving of the Earth's winds and even the curving and of the flowing the direction of the ocean currents. And that effect is known as the Coriolis effect, right? Which is another reason why we know that the Earth rotates, is another piece of evidence of the Earth's rotation. All right, number 8. Number 8 says, which landmass, right? Which landmass has at least one location where the sun will be directly overhead, where the sun will be directly overhead at solar noon at some time during the year. So one of the things that's very important that we have to know is that not everywhere on the earth will the sun be directly over an observer's head during solar noon, right? There are some locations on Earth where this occurs, and the Earth's tilt gives us an idea of that. Does anybody remember what is the angle of the Earth's tilt, right? The Earth's tilt is at 23.5 degrees. Now, why is this important? It's because the angle of the Earth's tilt also gives us a range as to between which latitudes will receive direct insolation, where the sun will be directly over an observer's head at a 9-degree angle. So I'm going to go to my reference tables page. And when I go to my reference tables, right, there are two latitudes, right, that the number, the angle represents also the same as the Earth's tilt. And it is the Tropic of Cancer, 23.5 degrees north, and the Tropic of Capricorn, 23.5 degrees south. And so that means that in this range, only in these between these two latitudes, right? That means everywhere else on the earth, within these two latitudes, everywhere within these two latitudes, at some point throughout the year, the sun will be directly over our head, right? At a 90-degree angle. That's one of the reasons why we know, for example, right, New York, which is located somewhere around here, it's outside that range. And that's why New York will never get 90-degree sun rays from the sun. So now when I'm looking in this range and I'm looking at the options that were provided, right? Which of these land masses will the sun be directly overhead, right? Antarctica, well, Antarctica is outside this range. So, nope, that can't be it. Let's see, Europe. Europe is outside this range. That can't be it. Greenland is outside this range. That can't be it. However, Australia, there is a part of Australia, right? Right here. There's a part of Australia that is inside of this range, right? And so that's the reason why part of Australia at some point throughout the year will receive at least a location in Australia will receive 90-degree sun rays, right? The sun will be directly overhead at solar noon. So the correct answer is choice 2. Number 9. Number 9 says, what is the primary source of energy that causes all weather phenomena on Earth, right? So I know one of the things that affect weather on Earth, right, is the unequal heating. The unequal heating that takes place on Earth. And what do I mean by unequal heating? We actually experience this, right? Just giving an example. We know that there is more energy from the sun that's concentrated at the equator, right? There's more energy that's concentrated at the equator than at the poles, right? And so because of this, the equator is generally warm, right? And at the poles is generally cool. And because of this unequal heating that takes place, right, on the earth, this is how we get developed of pressure systems, right? And of the different type of air masses that are eventually moving all around the earth. And so what choice resembles, right, that the reason why we have weather phenomena is due to, the unequal heating that takes place on the earth, that comes from incoming solar radiation. And so the correct answer is choice 4. All right, number 10. Number 10 says the dry bulb temperature. All right, oops, there we go. The dry bulb temperature is 18 degrees Celsius, and the wet bulb temperature is 8 degrees Celsius on a psychrometer. What is the dew point? All right. Well, when I'm looking for the dew point, there is a page on the reference tables that emphasizes, right, for me to find the dew point using the dry bulb temperature and the wet bulb temperature. What page is it, everybody? Let's take a look. And we are at page 12. And on page 12, we see the chart, right, about dew point. We see about dew point in degrees Celsius, and we also see about relative humidity. And what's interesting about this chart is those terms that I highlighted, right? Dry bulb temperature and wet bulb temperature. I also see these right here, right? Wet bulb and dry bulb temperature, dry bulb temperature. So somehow I'm going to use the dry bulb and the wet bulb temperature to find out the dew point. Now, keep in mind, all of these numbers in these boxes, all of these represent dew point temperatures in Celsius. All right, all of these numbers inside these boxes represent dew point temperature. So now when I look at my problem, it says my dry bulb temperature is 18 degrees Celsius and the wet bulb temperature is 8. All right. Oh, let me go ahead and refresh it. Okay. So therefore, my dry bulb temperature is 18 degrees Celsius. So I'm going to circle 18 degrees. Now, to use this chart, I need to know the difference between the wet bulb and dry bulb temperature. So if my dry bulb temperature was 18 degrees Celsius, oops, sorry, and my wet bulb temperature is 8 degrees Celsius, right? What is the difference? Well, 18 minus 8 gives me 10, right? So because they have a difference of 10, I'm going to highlight the difference of 10. Now I'm just going to match them up. And when I match them up, you'll realize that my final answer will end up being -5 degrees Celsius. -5 degrees Celsius ends up being my answer, which is choice 1. All right, number 11, the polar front jet stream in Earth's atmosphere is located in the upper what? In the upper what? So I know that jet streams, right? Polar front jet streams, right? They play a role with how we have air masses that are flowing, right, from one place to another. They play a role with weather systems that are traveling all across pretty much the world, right? And if I was to use America as an example, I know this is a very horrible picture of America, but we can have jet streams, right? And I'm just giving an example. And in this jet stream can definitely allow for weather systems to travel, right? So we know that weather needs to take place. It plays a role. When I'm looking, right, I'm looking and I'm just like, I don't remember about jet streams. I know it has something to do with weather, right? And when I'm looking at these names, where do I find all these names, right? That's talking about the Earth's atmosphere. It's on page 14 of the reference tables. All right. So I know one of these layers have to tell me, right, where jet streams travel from. Well, because I know that jet streams have something to do with weather, right? And we know with weather has something to do with the amount of water vapor, right? That is occurring. We know that most of our water vapor concentration actually occurs, right? We see where it says 40, right? Most of the water vapor actually occurs in this layer. And so just like most of the weather phenomena that even occur on Earth actually occur in the troposphere. That's where most of our weather phenomena occurs, in the troposphere. So the correct answer is choice 1. Number 12. So number 12 says, which two weather symbols represent severe weather? severe weather, right? So weather that is nasty, horrible, possibly even dangerous, right, to us humans in society. And so when I'm looking at these weather symbols, right, there is one page on the reference tables that talk about these weather symbols. What page, everybody? Page 13. And take a look at the present weather, right? And the weather symbols that are here. And we also have some weather symbols that are located here as well. And so when I'm looking at some severe weather symbols, right? I definitely can highlight thunderstorms, can definitely be one. I could even say even hail, right? I definitely can say, right, hurricanes, tornadoes as well. So I'm gonna look at my options and I'm gonna look to see, all right, which one of these actually shows severe weather. And when I'm comparing the two, my best answer is definitely going to be 3. Because if we look, this symbol actually represents thunderstorms. And this symbol right here actually represents tornadoes. And so this has the best combination of severe weather, which is choice 3. All right, people, let's keep on going. Number 13. Number 13 says compared, right? That word compared to the average air temperature at the stratopause, right? The average air temperature at the mesopause is. So at the end of the day, my final answer has to deal with the mesopause compared to the stratopause. Now, these terms, stratopause, mesopause, right? Where do I even find these on the reference tables? Once again, I'm looking with the lens of how can the reference table help me to solve these problems, right? Well, I see mesopause and I see stratopause on page 14 of the reference tables. All right. And so the question says that I'm looking for the average air temperature of the mesopause, right? And comparing it to the stratopause. Well, the mesopause has a temperature of what? Negative 90 degrees Celsius. All right. And the stratopause, I'm gonna put a different color. Let me use the color red for the stratopause. The stratopause has a temperature of what? 0 degrees. So I know that the mesopause is at not negative 90 degrees Celsius, and the stratopause is 0 degrees. So when I look here, right, and let me, the stratopause we just said was, sorry, whoops, let me take a look. Yep. The stratopause is 0 degrees Celsius, and the mesopause that we've learned is negative 90 degrees Celsius. So, what is the average air temperature at the mesopause compared to the stratopause? If the mesopause is negative 90 degrees Celsius, then that means it's going to be 90 degrees Celsius lower than the stratopause, right? Because it's negative. All right, number 14. Number 14 says, which atmospheric gas is important because it protects living things on Earth from harmful ultraviolet radiation, right? What gas, right, protects us from ultraviolet radiation? Well, when I look, right? And this is just something that we should know. The ozone layer protects us. The ozone layer actually protects us from UV radiation, right? And so the ozone layer is a layer full of ozone gas. And so that's why the correct answer is choice 2. All right, everybody. So we're looking at question 15. So it says equal areas of which surface absorb the most insulation and heat up most rapidly on a sunny day. So remember that remember that objects that are dark and rough absorb, right? Absorb insulation the fastest. So that's something to keep in mind. So therefore, we can cross out choice 1 and 3. Why? Because of the fact that they are lightly colored objects. They're lightly colored objects. And then when I look at choice 2, right, calm lake surface, remember that water takes a long time to heat up, right? Because it has a high specific heat. It has a high specific heat. And so therefore, objects that are dark and rough, right? My best answer would be choice 4. Why? Because basalt, right, is an igneous rock. And when I look at basalt, basalt is in the category that has a dark color. So that's why it reflects the fact that the correct answer is choice 4, right? Crushed basalt rock. It's a dark and rough object which absorb the most insulation. All right, last but not least, number 16. So number 16 says many periods of global warming have occurred during the last 100,000 years. The inferred primary cause of the current rise in global temperatures is the blank, right? So when I'm thinking, what is the reason? What is the reason as to why the global temperatures are rising, right? What is the main reason why global warming is occurring? It does have to do with the increase of greenhouse gases, right? And the purpose of greenhouse gases is that it absorbs and re-radiates infrared radiation, which is also known as heat. So if these greenhouse gases are absorbing infrared radiation and re-releasing it, is going to cause for the Earth to be warmer. And so that's why the correct answer has to be choice 3. All right. Thank you guys so much. Please make sure to like, share, and subscribe. And by all means, have a wonderful, blessed day. Take care, people.